Does liquid water recently exist on today's surface of Mars? This question is critical for understanding the recent climatic evolution of the polar ice caps, the habitable environment, and even the potential for life on Mars. We know that abundant liquid water existed on early Mars. However, as the early atmosphere has disappeared, the climate and environment on the red planet have undergone substantial changes. The planet has always been in the foreground in searching for life. Not only NASA is working for that, but also China. A recent study claims that a Chinese rover settled on Mars in 2021 may have found the evidence. This is Spaces. Now scientists believe only solid or gaseous states of water can exist on Mars. The reason is that climate change caused gigantic reserves of liquid water to dry up in the planet's ancient history. But China claims they have found evidence of liquid water at low latitudes where temperatures are relatively warm and more suitable for life. To be honest, it is a provoking claim. The finding also highlights that there's still a chance of discovering evidence of ancient life, even habitable areas on the planet's current-day surface. Mars has an incredibly thin atmosphere, and this makes it almost impossible for liquid water to exist on the planet. A piece of news regarding a finding of liquid water by Phoenix Mars lander stirred scientists who look for clues. Salty droplets of water that landed on the arm of the lander, which touched down on Mars in 2008, led scientists to believe that liquid water was able to exist at high latitudes on Mars. However, it was a conclusion that proved controversial at the time. Now a team of Chinese scientists thinks that liquid water may also be able to exist at lower altitudes. The spacecraft is called Jerome. Its scientific instruments are tasked with analyzing surface features and the composition of dunes. Data from these instruments suggest their surface layer is rich with hydrated sulfates and silica, as well as oxide minerals. According to researchers, this salt allows for ice or snow to melt at lower temperatures. On the other hand, they say no water ice was detected by any instrument. The researchers suggest humid environments throughout the planet's history allowed for frost or snow to repeatedly melt and refreeze. They think it caused crusts and cracks to form on the surface, leaving behind liquid salty water. On the surface of Mars, the dunes are anywhere between 400,000 and 1.4 million years old. According to the research, these dunes were once rich in these hydrated sulfates and minerals. This is important for understanding the evolutionary history of the Martian climate because we look for a habitable environment and key clues for the future search for life. The researchers also call for future Mars missions to focus on searching for salt-tolerant microbes to reveal the remaining life on the red PLA.